Imagine looking up at the night sky and seeing a fiery streak racing toward Earth. Not a shooting star, not a meteor shower, but an asteroid, massive, unstoppable, on a collision course with our planet. It sounds like science fiction, but it's not. Throughout Earth's long history, asteroids have struck our planet again and again, with devastating consequences. The most famous? The Chicxulub impact, 66 million years ago. A 10-kilometer-wide asteroid slammed into what is now the Yucatan Peninsula in Mexico, triggering a chain reaction that wiped out the dinosaurs and nearly 75% of all life on Earth. That wasn't a close call. That was a reset button. So the question is, what if it happens again? And more importantly, can we stop it? Welcome to Infinity Beyond, where today we explore the cutting-edge science of planetary defense, Earth's line of protection against cosmic impacts. Let's start with the basics. Every year, Earth is bombarded with more than 100 tons of space material, mostly harmless dust and pebbles that burn up in the atmosphere. But once in a while, something bigger sneaks through. In 2013, a 20-meter-wide meteor exploded over Chelyabinsk, Russia. It released 30 times more energy than the Hiroshima bomb, shattered windows in 6 cities, and injured over 1,500 people. And that was a relatively small object. Now imagine an asteroid hundreds of meters across, or a kilometer, or more. To face that kind of threat, we need more than hope. We need a plan. The first step in planetary defense is detection. NASA's Near-Earth Object Observations Program, also known as SpaceGuard, tracks thousands of asteroids and comets that come close to Earth's orbit. These objects are called Near-Earth Objects, or NEOs. NEOs are classified based on size and proximity. The ones we worry about most are potentially hazardous asteroids, PHAs, those larger than 140 meters and that pass within 7.5 million kilometers of Earth. To find them, astronomers use optical telescopes, radar imaging, and soon, a new generation of space-based infrared observatories like NEO Surveyor, set to launch in the coming years. But detection isn't enough. Once we find a threat, we need a way to deflect it. And that brings us to one of the most ambitious experiments in planetary defense history, DART. In 2022, NASA's Double Asteroid Redirection Test, DART, became the first mission ever to intentionally crash a spacecraft into an asteroid to change its trajectory. Target: Dimorphos, a 160-meter-wide moonlet orbiting a larger asteroid, Didymos. Goal: hit it hard enough to slightly alter its orbit, a proof of concept that we can deflect an asteroid without blowing it up. The result? A stunning success. DART struck Dimorphos at 6.6 kilometers per second. Observations from Earth showed that its orbit changed by more than 30 minutes, far exceeding expectations. This wasn't just a test, it was a turning point. It showed that kinetic impactors, spacecraft designed to slam into asteroids, are a viable method of planetary defense. But that's only one method in our planetary defense toolbox. Let's explore a few more ideas scientists are actively researching. Gravity tractors. A spacecraft could fly alongside an asteroid for months or even years, using gravitational attraction to subtly pull the asteroid off course. It's a slow process, but very precise. Ion beam shepherds. By directing a continuous stream of ions at an asteroid, a spacecraft could gradually push it at using the force of particle momentum. Think of it as space-level pressure washing. Solar sails and paint. Yes, even painting an asteroid could help. By altering its albedo, reflectivity, we can change how it absorbs sunlight, thereby tweaking its path via the Yarkovsky effect, a real force caused by thermal radiation. Nuclear explosions. Considered a last resort, detonating a nuclear device near an asteroid's surface could either vaporize part of it or nudge it off course. Unlike in Hollywood movies, the goal isn't to blow the asteroid to bits, but to create a controlled force that alters its trajectory. Each method has pros and cons. Timing is critical. The earlier we detect a threat, the less force we need to deflect it. But what if we don't catch it in time? That's where emergency response plans come in. Space agencies and governments run regular simulations, called planetary defense drills, where they model what would happen if an asteroid were heading toward Earth with just months to spare. In these scenarios, they consider evacuation plans for impact zones, strategies to protect infrastructure, communication protocols to prevent mass panic. One such simulation in 2021, coordinated by NASA and ESA, imagined a fictional asteroid on track to strike Europe. The outcome? We couldn't stop it in time. The message was clear: early detection is everything. So, how prepared are we, really? As of now, astronomers have cataloged over 90% of NEOs larger than 1 kilometer. But for objects between 100,000 to 500 meters wide, the ones still capable of regional devastation, we found only about 40%. That's why the next generation of sky-scanning telescopes is so critical. One of the most anticipated projects is the Vera C. Rubin Observatory in Chile. Once operational, it will scan the entire sky every 3 nights, dramatically increasing our ability to detect smaller, faster, and more elusive space rocks. We're in a race against time, not because an asteroid is headed for us now, but because we know one day one will be. It's not a question of if, it's a question of when. But here's the good news. We're no longer passive observers of fate. For the first time in human history, we have the technology, the knowledge, and the will to defend our world. Think about that. A species that once feared the sky now sends machines into space to protect the planet. We've gone from gazing at stars in wonder to pushing back against cosmic threats. And that's just the beginning. In the next episode of Infinity Beyond, we shift our focus to a deeper question. What if we find evidence that an asteroid impact created life instead of destroying it? Could the seeds of life have arrived on a meteorite? And if so, what does that mean for our origin story? Subscribe now and join us as we explore the fine line between destruction and creation, between extinction and evolution. The universe may be dangerous, but it's also full of wonder.